on May 29, Saturn asked a question that sounds impossible. How long is one day? Because on rocky worlds, you can just watch a mountain come back around. But Saturn is mostly gas, meaning the surface you need keeps slipping away. So for decades, astronomers made a risky choice. They listened to the planet because Saturn's magnetic field sends a radio beat once each rotation, and that sounded beautifully simple until two spacecraft disagreed. Voyager heard 1 day as 10 hours and 39 minutes, then Cassini heard 10 hours and 45 minutes, roughly one Earth commute longer. 6 minutes is tiny for us, but huge for a planet's spin clock, because a world that could swallow 700 Earths cannot casually change pace in 20 years. Then it got stranger, because Saturn's north and south seemed to keep different time, so the clock we trusted began to look less like a clock, and more like weather moving through a magnetic machine, which means by the end, the rings may be the only clock still steady, so the first cascade begins with a clock that should never drift, because Voyager heard Saturn repeat in 10 hours and 39 minutes. That sounds precise, until Cassini returns 2 decades later, and the same radio beat points to 10 hours and 45 minutes. 6 minutes is tiny for you, but enormous for 700 Earths because a planet that large cannot change spin like that. So astronomers realize the radio pulse is not the rotation itself, it is a signal braided through Saturn's magnetic weather, where the north and south seem to keep slightly different time. Now the anomaly gets stranger, because both clocks came from auroras, and auroras sit above the atmosphere, not below the rings, which means the clock was probably moving somewhere between air and magnetism, not in the deep interior that carries the real day, so Saturn kept spinning, while that chosen clock kept drifting, and the aurora was not just glowing for us, it was heating the air above Saturn's clouds, and that heat pushed thin winds around the magnetic pole. Those winds dragged charged gas, meaning tiny electric currents began moving, and those currents fed energy back into the aurora again. So the signal became a clock with weather inside it, where a storm high above the clouds could blur the beat. And this is the human cost of a wrong clock, because every model using that pulse inherited the wobble, from storm maps to interior guesses, from papers to textbooks. For decades, you could teach Saturn and still miss its day, which is why the correction feels small until it lands. We had confused Saturn's breath for its heartbeat, and the rings kept ticking through every mistaken measure, until Webb finally pointed at the clock that kept lying, and the clue was not deeper inside Saturn, but above its poles. There, auroras heat the upper air, meaning Saturn starts making weather, and that weather pushes high-altitude winds around the magnetic field. Those winds drive electric currents. So the aurora feeds itself again, like a microphone too close to a speaker, looping its own signal. So the radio beat was real, but it was not Saturn's spin, it was the planet's upper air, rewriting the clock hand from above, while the rings kept the steadier rhythm below, 10 hours, 33 minutes, and 38 seconds, carved into waves you could miss from Earth. That is the quiet twist. We mistook breath for heartbeat, and once you hear that, the Voyager number changes meaning, because it was never a bad clock, just the wrong clock, and the rings keep ticking for the next impossible question.